All right, now we are going to talk about the mean value theorem. First, we are going to understand the definition of the theorem, and we are going to solve the example based on that. Here is one situation to represent the theorem. I'm also going to draw a second diagram to represent the theorem. So I'm going to draw the x and y axis here. If you want to add them to your note catcher, you can definitely do this. Suppose that is my x and y axis. Now I'm going to consider the function like this one. If the function y equal to f of x, so I'm going to take a function y equal to f of x. Say, for example, that's my function y equal to f of x, which is continuous on the closed interval ab. So if I want to take an interval ab, that is an interval from a up to b, so maybe interval is starting here along the x-axis at x equal to a. So x equal to a is the value on the x-axis. X equal to a up to maybe some point there. Let's say x equal to b. So in this closed interval, when I say closed interval, I'm also taking the endpoint. These endpoints are also considered. So from here all the way up to there, the function is continuous on the closed interval, and also differentiable on the open interval. So if you want to find the derivative at any point inside this, over here, you must be able to find the derivative. So in order to find the derivative, the function must be continuous. So definitely you must be able to draw the tangent line at that point. So that is possible here. So if you have a function like this, which is continuous on the closed interval from a through b, and also differentiable on the inner point or inside of that interval, then there is a point C in this interval. So between A and B, here in the middle, somewhere in the middle, there is a point C, such that this part is true, or this condition is true, f of b minus f of a over b minus a. Now let's try to analyze what is this one, f of b minus f of a over b minus a. If you want to look at the points on this function, the point over here at x equal to a, the point is a comma f of a. So we can label that point as a comma f of a. That is the point there. And if you want to label this point, it's at x equal to b. So the x coordinate is b, and the y value will be f of b. So these points are f of a comma f of a and b comma f of b. And if you want to look at this carefully, it is f of b minus f of a over b minus a. That's like y2 minus y1 over x2 minus x1. So this is same as the slope of the line connecting these 2 points. So if we draw a straight line there, then it will be the slope of that line. So the left-hand side of the equation is the slope of this line, slope of the secant line. Slope of the secant line is equal to, when we say f prime c, f prime is the derivative is the slope of the tangent line. So we'll be able to draw a tangent line somewhere here so that the slopes are equal. And when we say the slopes are equal, meaning of that is the lines are parallel. So maybe somewhere here, if I draw a line like this, you can see that the lines are parallel. These two lines, they look parallel. So what we have seen is somewhere at this point, which is at x equal to c, maybe somewhere here, let me label that. Somewhere over there, so this is at x equal to c. So at x equal to c, you'll be able to draw a tangent line whose slope is equal to the slope of the secant line. So that's always true. If you have a function that is continuous on the closed interval and you can find the derivative in the closed interval, then you will be always able to find a tangent line which is parallel to the secant line. So that is the main idea or the statement of the mean value theorem. Example, determine whether the mean value theorem applies to the function f of x equal to 7 minus x squared on the interval -1, 2, that's the closed interval -1, 2. If the theorem applies, then if so, we have to find the point or points that are guaranteed by the theorem. So what I'm going to do is first I'm going to represent the function, or I'm going to graph that function. Let's graph that function together. Suppose that is my y-axis. This is my x-axis. Our function is 7 minus x squared. So it's a downward facing parabola. So let's draw a downward facing parabola with the y-intercept 7 units. So this is the downward facing parabola y equal to 7 minus x squared. Y-intercept is 7. So this point here, it will be 0, 7. And then because we have 7 minus x squared as the function, x-intercept will be negative square root of 7, 0. And then this one will be square root of 7, 0. Square root of 7 is more than 2 but less than 3. So this value is more than 2 and less than 3. So it will be 2 point something. Now we are interested in the interval from -1 up to 2. So -1 up to 2, if you want to mark that on the graph, so -1 will be somewhere here. So first we are going to look at that. -1 should be somewhere there in the x-axis. So that should be x equal to -1. So let's write that. That is x equal to, let me use different color now. X equal to -1. We are going from x equal to -1 up to x equal to 2. So this is 2 point something. So x equal to 2 should be somewhere there. So let's represent that. So that value is x equal to 2. And these are the endpoints on the graph. This dot and this dot, these are the endpoints on the graph on that interval. Now the first part of the question says, determine whether the mean value theorem can be applied to this one. If the mean value theorem is applied, then the function must be continuous. Look at this function, it is continuous. You will be able to find the derivative everywhere inside. That means this function is also differentiable. So mean value theorem can be applied, but you have to write that down. So here, f of x equal to 7 minus x squared is continuous on the closed interval -1 up to 2 and differentiable on the open interval -1 to 2. That means mean value theorem can be applied to the function. Mean value theorem can be applied to the function. And if you remember the mean value theorem says f of b minus f of a divided by b minus a is equal to f prime c, where c is in the interval from a through b. C is a point inside the interval AB. C belongs to the interval AB. That means first I need to find f of b minus f of a over b minus a. So in order to find f of b minus f of a over b minus a, this is your a, this is your b. So I need the points on the graph. So if I want to find the points on the graph, what I have to do is I have to plug in the values. So for the first one, if I plug in -1, 7 minus -1 squared. -1 squared is 1. So 7 minus 1 is 6. So this point is -1, 6. -1, 6. And this point will be, if I plug in 2, it will be 7 minus 2 squared. 7 minus 4, that is 3. So this point is 2, 3. 2, 3. And I want to find f of b minus f of a over b minus a. That means I want to find the slope of the secant line joining these points. So I need a secant line joining those 2 points, and I have to find the slope of that secant line. So let's try that. Let me draw that line there. First of all, let me draw that line. So you can see that is your secant line. And we want to find the slope of this secant line. So let's do that now. Slope of the secant line, that is f of b minus f of a over b minus a, which is equal to f of b is 3, f of a is 6. So it becomes 3 minus 6 divided by b minus a, b is 2 minus a negative 1, that is 2 plus 1, which is equal to negative 3 over 3, that is equal to negative 1. So slope is negative 1. Next, we have to find the derivative at c. So for that, let's find the derivative. Also, the derivative of the function. The derivative of the function is derivative of 7 minus x squared. Derivative of 7 is 0, and then minus derivative of x squared is 2x, so it will be negative 2x. Negative 2x. But what I want is, I want the derivative at c. So derivative at c means in place of x, I'm plugging in c. So that is equal to negative 2 times c. Negative 2c. So we have this value, f of b minus f of a over b minus a. And also we have f prime c. F prime c is here. But this function satisfies the mean value theorem. So when the mean value theorem is true, these two values must be equal. So by mean value theorem, those two values are equal. So we can write by mean value theorem, let me write that here. By mean value theorem, this one, negative 2c must be equal to negative 1. Negative 2c must be equal to negative 1, which implies c equal to 1 over 2. We are asked to find the value guaranteed by the theorem. So theorem guaranteed that c is equal to negative 1 over 2, which is in the interval. You know, this half is in between these values. It is somewhere inside this. So that is in the interval negative 1 up to 2. So the point guaranteed by the theorem is c equal to 1 over 2. So we can write, so point guaranteed by the theorem, guaranteed by the theorem is c equal to 1 over 2. That means at c equal to 1 over 2, okay, at c equal to 1 over 2, if I draw a tangent line, it will be parallel to that. So you can try that. So if we try to draw the tangent line that is parallel to that, maybe it will be something like this. Let me try to draw it properly. You can see they look parallel. And also, you can note one thing there. The value at which we have this tangent line, if we try to find that value on the x-axis, so this value is x equal to half. So at half, between these two values, we can draw a tangent line which is parallel to this secant line. So that point x equal to 1 over 2, which is in this interval, is the value guaranteed by the theorem. Example, determine whether the mean value theorem applies to the function f of x equal to sine inverse x on the interval 0, 1 over 2. So this is the graph of the function f of x equal to sine inverse x. We are interested in the interval from 0 up to half. So if you want to locate those 2 points on the x-axis, x equal to 0 is here. That is x equal to 0. And x equal to half will be somewhere there. So corresponding to these points, the point on the graph is that point. And if you look at this segment of the graph from here to here, you can see that the function is continuous. And also you can draw the tangent line everywhere on this, meaning of that is it is differentiable. So the function is continuous on the closed interval, differentiable on all inner points. So we can say that the mean value theorem applies to this function on that interval. So let's first write that. Here, f of x equal to sine inverse x is continuous on the closed interval 0, half and differentiable on the open interval from 0 up to half. So this implies the mean value theorem can be applied to the function. So we can apply the mean value theorem to the function. And the mean value theorem, you know the mean value theorem. Mean value theorem says f of b minus f of a divided by b minus a is equal to f prime c, where c is in the interval a up to b. So for this function, what you have to do is we have to find f of b minus f of a over b minus a, and also we have to find the derivative at c. So let's first find f of b minus f of a over b minus a. Now, f of b minus f of a divided by b minus a is equal to, okay, our a is 0 because we are talking from x equal to 0 to x equal to half. So a is 0 and b is half. So f of b will be sine inverse half. Sine inverse half is pi over 6. From trigonometry, we know that. Then minus f inverse a. If I plug in 0, sine inverse 0 is 0. Then divided by, we have b minus a in the denominator, that is half minus 0. So half minus 0, which is equal to pi over 6 minus 0, that's pi over 6, divided by half. Pi over 6 divided by half is pi over 3. Pi over 3. So that is the value of f of b minus f of a over b minus a. We got this value. Now we need to find the derivative of the function at c. So first I need the derivative of this. So also the derivative will be f prime x is equal to the derivative of sine inverse x. Derivative of sine inverse x is 1 over the square root of 1 minus x squared. This implies the derivative at c, because I need the derivative at c. Derivative at c, we have to plug in c for x, so that will be equal to 1 over the square root of 1 minus c squared, because in place of x, I'm plugging in c. So once we have this, we are ready to apply the theorem. And the theorem says those two values are equal. The value of f of b minus f of a over b minus a and value of f of c, they are equal. So let's use the theorem and equate them. So you can write by mean value theorem, what you can say is pi over 3 is equal to 1 over the square root of 1 minus c squared. Now we have to find the value of c, which is there in the denominator. So what I'm going to do is I'm going to square this on both sides to get rid of the denominator. And also, in order to bring the c in the numerator, I'm going to flip the fraction on both sides. So if I square the left-hand side, it will be pi squared over 9, but I'm flipping that, so it will be 9 over pi squared, 9 over pi squared equal to, if I square this, square of 1 is 1, and square in the denominator will remove this square root, and when you flip it, it will be 1 minus c squared over 1, which is simply 1 minus c squared. I'm looking for c, so I have to bring that c squared on the left-hand side. It will be positive c squared. Move this to the other side and subtract. So it will be 1 minus 9 over pi squared. So which implies c is equal to square root of 1 minus 9 over pi squared. And if you find this square root using the calculator, the value must be approximately 0.3. And you know that this 0.3 is between 0 and half. Half is 0.5. So this is in the interval from 0 up to half. So C equal to 0.3 is the point guaranteed by the theorem.